And today I'll talk about container orchestration on Amazon Web Services platform. Just like everybody, I have a Twitter handle as well. So first of all, this is not a Docker 101 talk. So I presume you have basic understanding of what Docker is. But if we look at a very high level, what is it that the Docker containers really offer to us? Or what is the container workflow looks like typically? If you think about this, there are three components to Docker. There is a client, which is the Docker CLI, which is how you instruct to build an image or run a container. Then there is a Docker host, typically multiple hosts set up in a clustered environment, where you say, this is where my containers are going to run. And then there is a registry. It could be Docker Hub, could be Amazon ECR, or some third-party registry where your images are living. So your typical flow is the client would be pointing to a Docker host and say, OK, now go run my container. The host says the image does not exist. So it goes and talks to the configured registry, downloads the images, and then run the container. The important part here to understand is the client is completely stateless. Client gives a convenience command, say Docker run. It goes as a REST API under the hood. The Docker server or the Docker engine on the host is listening to that command. It receives that REST API, does all the things that need to be done on the host because the client is stateless, and then returns a response back to the client of whatever you expected it to be. Now, typically when you're building your application, that application will have multiple containers. Let's say you're running a few Nginx web servers, you're running a few Wildfly containers, and you're running a few MySQL containers. So very easily, when you start with an application, you typically have multiple containers running. And then you have these hosts, Docker hosts, so to say, multiple hosts of those running. So your application very quickly and very easily becomes a multi-host, multi-container application. And that's exactly the role that these container orchestration frameworks play. They essentially say, OK, you got to have a cluster of Docker hosts. Somebody needs to manage that. If a host goes down, what happens and that sort of behavior. And then when I am placing a container on a host, there needs to be a scheduling algorithm. Somehow I need to figure out that your container needs such and such memory and CPU, and I need to figure out which of the hosts has that capability, and I should be able to match that request. And if it doesn't happen to be so, then return the response appropriately. So that's exactly the role for container orchestration frameworks. So what I'm going to do today is, in the next, say about 45 minutes or so, give you a quick overview of 4 container orchestration framework. We'll look at the Docker Swarm, or the Docker engine itself, which gives you the orchestration framework. We'll look at Kubernetes, which is an open source framework originally created by Google and then donated to CNCF. Then we'll look at Amazon ECS, which is EC2 Container Service. And then we'll also look at Mesos. So let's get started first with Docker. Now, how do you do your development with Docker? Well, essentially, if you think about this, there is Docker Community Edition and Docker Enterprise Edition. You can go to docker.com. It will tell you on which version you want to start with. Community Edition is all out in the open source. Anybody can download the tools over there. Enterprise Edition is when you're ready to go into production, and that's where it provides some additional value-added features over there. Now, when you're doing development, then you have the option to say, I want Docker for Mac, Windows, or Linux. Because Mac is something that you do development on. That's not something that you go production with, essentially. Windows and Linux you can go production with. And then, of course, if you could do your development on AWS and Azure as well. So in that sense, if you can download a Docker Community Edition for Mac, Windows, Linux, and AWS or Azure. We'll talk about the AWS part in a second. Now, if you download the Docker CE or the Community Edition, the releases are done on a monthly basis. Those are bleeding edge releases. Anytime the code is put in there, they build it out, and then at the end of the month, pretty much they release something new. So that's your community, Docker CE, Docker for Mac, for example, releases. And then they also have stable releases, which are every quarter. But this is purely for development. Docker EE, on the other side, is also released quarterly, and it has a support lifecycle for up to a year. But our focus will be primarily on Docker for Mac. So this is a MacBook that I'm using. So all my development in that sense can be very easily done on a single box, very easily. In a single Docker engine, I can enable the orchestration and say, okay, now run my multi-container application. So how do I do? I have a single MacBook here. In that Docker, where I've installed Docker for Mac, and I could just simply say Docker Swarm init. And it is an optional mode, but it enables orchestration in your single Docker engine now. Now, if your MacBook has multiple network addresses or network interfaces, then you can say, I'm going to listen on this particular host or this particular IP address, and then the port on which you're going to listen. So this is basically a single host Docker engine running in a Swarm mode. Now, you could also run multiple VirtualBox on your Mac, and then each of those could be configured as a Docker host. And then you can say, my first node is always a manager, but now I want to add a worker as well, because I want to create a multi-host cluster, essentially. The difference between manager and worker is manager is responsible for the actual orchestration of the containers and the cluster itself. Worker is only where the containers are running. You could easily run up to a multi-host cluster. On this MacBook, for example, I've been able to easily run up to 6 VMs, VirtualBox VMs, and set them up as a Docker Swarm cluster. Okay. Now, you need to specify the token. And depending upon the kind of token that you specify, whether it's a worker token or a manager token, you could join the node to the cluster. So essentially, if you want, you can have a multi-master Docker cluster with multiple worker nodes around it. And this gives you the ability on how you can easily set up your cluster very easily for your local development. Now that's good for local development, because then all of that development is happening on your local machine, but you really want to simulate this on the cloud, and that's where you're going to Amazon Web Services. So Docker Inc., the company, and Amazon Web Services have partnered together to create what they call as CloudFormation templates. This is the Amazon language. So essentially the CloudFormation template, you take that CloudFormation template, you're going to say, I'm going to run this CloudFormation template in such and such region. So let's say you pick up US East or US West, whatever region you pick up. And then it's going to create all the resources that are required for you to spin up your Docker cluster. So it spins up your EC2 instances. It configures the master, it configures the worker. All of that configuration is automatically done for you. It also configures your workers and masters into auto-scaling group. And what that means is, if a node goes down, because of being in an auto-scaling group, the node will automatically come back up. It also configures a ELB, an elastic load balancer. So any services that you create in that Docker cluster can be front-ended with a ELB. It also has connection with EBS. So now you're running, say, stateful containers. So your state could be stayed on those EBS stores as well. So once again, you can download Docker Community Edition for AWS, or you can download Docker Enterprise Edition for AWS. So if I can switch to a browser for a second here. So here I am at docker.com essentially. And if I look at the very first link here, it says get Docker Community Edition. Okay, so I'm going to go here. I'm going to say get Docker CE from Docker Store. Now here is showing Docker Community Edition for Mac. That is good for my development here. These are all the Windows and the Linux. And then this is where I'm looking at Docker Community Edition for AWS. So if I go here, it can say get Docker for me here. And if I click on this link, this will essentially bring up my AWS console. And in the AWS console, it is actually pointing to a CloudFormation template. And then in the template, the link is automatically loaded for me, that where the template URL is. But now when I click on next, it's going to ask me, okay, what is your CloudFormation stack name? How many number of Swarm managers, how many number of worker nodes you want? Then you can start assigning certain Swarm properties. You can start defining your EC2 instances here. So let's say I want a M3 extra large here. Then you can say how much storage volume you want. Similarly, I can define for the worker Typically, I would like my worker to be a little bit larger size because that's essentially where my containers are going to be running. So maybe I can go here and I can say M4 extra large here. And once you have defined your instances, then you click on next here. Take everything default here. It just confirms everything looks good. Actually, if we can go back here, we can also choose SSH key, which allows us to interact with the cluster later on, because these are all essentially EC2 instances, and this will allow us to SSH into the instance as well. So now I go back here, next again. It confirms that, okay, can I create the IAM resources for you on your behalf? And then you click on create, and there it goes. So we'll come back to this a little bit later, towards the end of the talk, but you will see that how your cluster is automatically created. Now, your Docker Swarm cluster is created in AWS. All you need to do is use your Docker client on your local machine, point to that cluster. You can literally set up a tunnel, and then instead of doing the development on your local machine, the same Docker Compose file or the Docker images that were running on your local machine are now running on AWS. It's very seamless migration from your local machine to remote one. So we will wait for this to kind of spin up my cluster. But essentially, if I refresh it here now, you can see my CloudFormation template is in action. It's creating the resources, it's going to create the subnet, the VPCs, the storage volumes, all of that will be created for me. All right, let's switch gears. Let's talk a little bit about Kubernetes then. Now, we understand that Docker is the base, where your image is stored. That's sort of the most prominent format, although that is not the only format. So Kubernetes is an open source orchestration framework that was originally created by Google based upon their multi-year experience of running Borg. So essentially inside Google, any app that you think of that is backended by a container, and that's their own format of container. And that system they call as Borg. And in that Borg, about a couple of years ago, the numbers were quoted that they used to run 2 billion containers every week. That's a lot of containers running every week. So they do have experience in terms of Google scale on how to run that many containers and what could potentially go wrong with that. So Google essentially leveraged that experience and created Kubernetes. It's a brand new code base, but the experience is there. Now, the basic terminology for Kubernetes is pods. Pods is a co-located group of containers, Docker containers, that are shared together. Don't think of it as, my model, my view, my controller, or my Wildfly, my database, and my Nginx, they are co-located. No. You want them to scale independently. Think about your separation of concerns, and that's how you package your pods. So pretty much, think of it from practical purposes, one-to-one relationship between pod and container. But that's sort of the unit that they have identified as a basic unit. And the containers within the pod, they can talk to each other using localhost. They share the namespace, file system, all that. Now, pods, by the nature, are ephemeral. And what that means is, a pod is running today on one host. If the pod dies for some reason, it'll come up on a different host. It'll be given a different IP address. Now, that's not an IP address that you can rely upon, though, because the IP address can keep changing. Or for some reason, the node goes down, then the pod comes up on a different host. Now, think about your Java application talking to a database application. And if your database is running as a pod over there, you can't rely upon that IP address. And that's exactly where the concept of service comes in. Service is a single stable name that you can give to a set of pods all together. So essentially, your pod has a label, and that label is what is being observed by the service. And then service can say, anytime any pod comes up with that label, that pod becomes part of my service. And in this case, for example, I'm running 2 Nginx pods. They have a certain label, and service is sort of the front end for it. Now, my other pods can talk to the Nginx pods, not directly, but using service. And so this is how they really talk to each other, by using labels. Now, typically, you will not run a pod by itself. You would typically wrap it up in a concept called as replica set. And what that means is that, let's say I'm running my Nginx server or my Wildfly servers. Then I want the ability where those servers can replicate themselves. That means I can run multiple instances of the Wildfly servers. Depending upon the demands or the needs of an application, I should be able to scale the number of replicas up or down. And that's where replica set comes in. So all you do is you define your configuration in a YAML file. In the YAML file, you say, here is my service, here are my pods, here is my replica set, and then you pass that to Kubernetes and say, okay, now go ahead, create these resources. And then at the runtime, you can say, scale my replica set up and down, and that's the way your application looks like. So pretty much you have to take your application, break it down into the concepts of pod, service, labels, and replica set, and those are sort of the main concepts that you work with. Now on the ops side of it, just like Docker, there is a concept of a node here as well, which is basically a machine or a machine or a VM in the cloud. Now, of course, there's a master. Master has some key components. Just like Docker, there is an API server, which is listening for requests coming from a client. Docker has a Docker CLI. Kubernetes has kubectl or kubectl. It's lovely called as a kubectl. So the kubectl is where you take the configuration file and you give it to kubectl, say, go ahead, create these resources, and it'll create the resources for you. Then behind the scenes in the master, there is also a scheduler, because that scheduler is responsible. You got a 5-node cluster running in the back. Where should I schedule a particular pod? There is also a controller manager. So for example, replica set, which says, okay, you said create 5 replicas of this pod, and I'm responsible for those 5 replicas. But what that also means is, if a particular replica goes down, then I'm going to bring that replica or that particular pod up. Not that particular pod up, but at a given point of time, I will make sure that there are 5 replicas, because that's what you said. I'll make sure that that's running. And etcd is essentially where all the labels are stored, and that's a distributed watchable registry. On the worker side of it, of course, there is a Docker host running on it, even though Kubernetes supports multiple container formats as well. Well, Rocket being the other one, and they're also looking to support OCI compliant container format as well. But essentially, you have your Docker host running over there. That's where your pods and containers are running. And the Docker host or the kubelet itself is monitored by your operating system specific processes, so that in case it goes down, that process can come back up again. So let's take a look at our overall architecture of how Kubernetes would look like. Well, here we got our master. We have our kubectl, which is basically my client, where I'm going to give my configuration file that, okay, kubectl, go create these resources. Those goes to my API server. Behind the scene, again, is a REST API. I got my workers lined up over here. I'm just showing a 3-node cluster, 1 master and 2 workers, essentially. API server talks to the scheduler and the controller manager accordingly. And then he says, OK, now I need to go ahead and create these resources. Instead of creating the resources directly, it talks to kubelet. And kubelet says, OK, you know what? I'm going to create the pods on this particular machine. There's a proxy, which is what acts as a proxy to your pods. Now, on the right side, what I'm showing you is where my client is sitting. The client is talking to a load balancer. Could be like a F5 or an ELB load balancer, which then talks to the proxy to get the application being served. So this is essentially, if you think about this, in the middle is what is my Kubernetes cluster. On the top left is my client that is creating these resources. And on the right is where my client is actually accessing the application. Okay? So kubectl, as I said, is my entry point here, which is what controls my Kubernetes cluster manager. Once my cluster is created, I can say kubectl get pods, which is basically what my pods are running, how many pods are running, or I can say get nodes. That terminology used to be minions earlier. So you can say, show me the nodes that are running in there. You can create any resource. So you can say kubectl create -f and the resource configuration file. You can update or delete any resource. Now, let's say a replica set is one of the resources that you have created, and you want to change the number of replicas for that resource. So then you can easily say resize -- replicas, how many replicas, and replica set, and then the replica set name. Now, there are multiple ways by which you can run Kubernetes cluster on AWS. What I'm showing you here is, well, let's go to the link, actually. So the easy link for you to remember is, you can just remember the link, kubernetes-aws.io. That is automatically redirected to you for how Kubernetes is running on AWS. So there are literally 15 odd ways by which you can run Kubernetes on AWS. There are a couple of my favorites. I like to use kops a lot. Just the way kubectl manages resources for you on the Kubernetes cluster, think of kops as the kubectl for clusters itself. It kind of helps you manage the clusters, Kubernetes clusters. So kops is one of my favorites. I've played with that quite a bit, actually. Then there is Tectonic installer. That is pretty good as well. So let me show you a little bit about kops here. So if I go to kops, essentially, now this is the GitHub repo. You can see it's github.com/kubernetes/kops. I won't dig into the details of it, but essentially the key part here is, with kops, all you can say is, well, first of all, it allows you to create a multi-master cluster very easily. Let me show you one of the command line configurations here. There's a full detailed tutorial over here. Essentially, you need to create an IAM user where it needs specific access here. So you need to give those access to your account. Up until 161, you have to configure a DNS server because that's where all the information is stored about. That's where your API server is hosted. So that's something that additional work required on your side of it. But 162 was literally released this morning, and it has some gossip-based protocol where you don't have to set up the DNS server. So things are already improving a lot in terms of 162. You also need a S3 bucket where your cluster state is going to be stored. So let's say, shit happens, the whole cluster comes down, but then your cluster state is stored in an S3 bucket. The whole thing can come back up again because of auto-scaling groups and things like that. What version of Kubernetes is being used, so this can automatically come back for you. So really, what you need to do is, you're going to say, what is my cluster name? What is my kops state store? Right now, it's only possible to persist your state store in S3 bucket, but there are other persistence mechanisms that are already being discussed. But you just export these two variables, and then you can say kops create cluster, and I'm saying zones US West 2A. So essentially, what I could do is I could spread my masters across multiple availability zones in a region. You can only create a cluster in a region, not across region. For that, there is federated clusters. But if you're creating your cluster in a zone, you can easily have your masters across multiple availability zones. You can have your workers spread across multiple availability zones. So if I go to my shell here, if I show you kops help here, it can show you the different commands that are available. So you can create a cluster, delete a cluster, update a cluster. But then if I go further here, when I say create cluster, it shows me different options. So here I'm saying the zones in which to run the cluster. So you can say, okay, this is where my worker nodes need to be split across. And then if I know that in US West 2, there are 3 zones, so 2A, 2B, 2C, I can set up those different zones, and then my worker nodes are spread across those availability zones for higher availability. Similarly, there's a master zones string as well. So you can say, now go ahead and spread my master across multiple availability zones. So all sorts of fancy combinations are available. It also provides support for rolling update of your cluster. So for example, let's say you're running on Kubernetes version 157, and now your 166 is released, which is what is being supported by, or 162 rather, which is what is supported by kops today. Then you can say, kops, do the rolling update. So it'll update all the masters, and then it'll update all the workers. And without you doing anything, kops will take care of it. Now, the important part to understand here is this is not a managed service. So this is still on you to manage the cluster, essentially. All right, so that's my second container orchestration framework. Now let's take a look at the third container orchestration framework, which is Amazon EC2 Container Service. Now, Amazon EC2 Container Service is a high-performance, highly reliable fully functional, fully managed service by Amazon. That's one of the biggest advantages of it. So from your side, there is no management that is required. Just like any AWS service, you go to aws.amazon.com/ECS, and you say, I want to deploy a container. And that container, just like there is in Kubernetes, there is a concept of a pod. In this case, you create a task. Okay? So let's talk about the concept first. In terms of ECS, it provides you full cluster management. All of that cluster orchestration, the management, where the instance is running, that is completely behind the scenes handled by AWS. It provides you container orchestration, so it has the bin pack scheduling mechanism by which it accordingly figures out where your container needs to be placed, and it looks for the same availability zones and all those concepts that you're used to, particularly working with AWS. And the cool thing over here is because it is a product by AWS, it has a full deep AWS integration, and I'll touch upon some of those points a little bit later. So how does it work? Well, first of all, we have to have EC2 instances that are becoming part of our cluster. So when I go to ECS, and I'll show that to you in a second, I need to create a cluster, and as part of that cluster, I need to define, I need a 6-node cluster. So those are called as container instances. Then I need to have services, because I'm running essentially services over here. So if I think about my typical application where I have a front end, a middle tier, and a back end, those would be my 3 different services. And each of the services will have tasks. Now, services is a way by which you scale the task. So essentially, front-end service will have a task, but it could have multiple instances of the task. Similarly, my back-end service will have a task, and it could have multiple instances of that task. Now, this is a very classical example here. Let me see if I can walk you through this one here. Okay. So on the very outer edge, what you see is the AWS cloud. Then what I'm doing here is I have my ECS service, sort of the second big square over there. Now, when I'm creating my ECS service, my service is distributed across 2 availability zones, identified by AZ1 and AZ2. And then in the AZ1 and AZ2 is where my container instances are running. And in those container instances, essentially, is where my tasks are running. So if I want to scale the number of instances of a task, all I say is service scale up. If I want to scale it down, of course, I say service scale down. So what is sort of the deep integration with AWS essentially over here? Now here, I can specify IAM role to be used by the containers in a task. So right away, you can start identifying that, okay, this service should be running in this particular IAM role, and that integration is possible. The service can deploy and scale very easily and very quickly, and it has all that integration built in. So for example, AWS has code pipeline and code build tools, so you can trigger from there that anytime there is a change over there, go ahead and scale my service or deploy my service over here. You can also set up your service to scale up or down based upon CloudWatch alarms. CloudWatch is a monitoring system within AWS. So anytime you can set up that such and such alarm happens that, okay, my CPU has increased to 60%, automatically scale my service up. Or you can set up your alarms completely specific to your application. You can audit through CloudTrail, so it provides you full non-repudiation. So you have a full trail of events that have happened on how your services have scaled or how your service to task and role association looks like. Another cool thing that is with ECS is ALB, or Application Load Balancer. Now, you can expose each service as an ELB, a very classic ELB, but then for each service, you will have a separate ELB, essentially. What we recommend to our customers or developers is have an application load balancer, in which case the request comes to ALB, and then based upon your header or your path, you can redirect to the appropriate service. So that way, you're creating a single ELB instance as the front end to your application, and then you can route it to the right service, which then goes to the right task based upon your application needs. So what you do is you create a simple task definition. In this case, I'm saying I'm going to use the image of jboss/wildfly. The image name is certainly not correct here. I can define the soft limit and the hard limit for the app, for the container, for the task in this case, for example. I can do my port mappings that's shown towards the end here. And then I can configure my service. Well, you know what? Let me show you in the console itself. So here I am in my, let's get into the console first. So I'm in my console here, and I'm going to pick up EC2. Well, let's search it the way you would do this. I want to do something with containers, so I get my EC2 container service here. And I can say get started. Well, as part of the container service, of course, I can run the containers, or you can say, I just want to host a registry where I'm going to be hosting my Docker images. So you can do either of those. But for now, I just care about spinning up my containers. So then I can say continue. There are some pre-built samples available for us, but what I can do is I can define the task definition. I can give it the container name. And here I can say I want the Wildfly container to be running here. This is a Wildfly container, so I want to give it at least a megabyte of memory. And then I want to define my port mapping here. I can click to next step here. Then it's saying, okay, this is your sample web app. How many number of tasks, how many instances of the task you want to run here? I can click on 2, for example. I don't want any load balancing at this point of time. This can always be configured later on. And then I can click on next. By default, it says, okay, you're going to use a T2 micro. But here I can change that, okay, I'm looking for M2 extra large. And because you have said 2 tasks, it would like to make your task being distributed or highly available. So I can set up 4 instances in this case. And once again, I can set up the key that I care about. I can define the ingress, my firewall ports, etc. I can define the IAM role. It says review and launch. And at this point, if I click on launch instance and run service, this is basically going to go behind the scene, run a CloudFormation script, and set up a 4-node cluster for me, create those task definitions, all of that. Now, this is good from the console perspective as a first experience, but very quickly you want to automate this. So essentially, your task definition, all of your commands, etc., can be configured as a JSON file. And there is, of course, AWS CLI. That's something that I've been playing with. So you can literally create your cluster, create your task definition, deploy your services, scale your services, do all the CloudWatch, alarming, all of that using the CLI. There is no need to go to the console, essentially, as a matter of fact. So all of that can be very easily automated. So in that sense, it is very ops-friendly as well. In terms of other services, yes, there is ELB that we talked about, where it can be configured as a classic ELB or application load balancer, which does the load balancing based upon your host header or your path. It integrates with EBS, VPC. It automatically creates a VPC. Or you could say, no, I have my own VPC. Run this ECS container or ECS cluster in my own VPC as well. We talked about CloudWatch, how you can actually set up a CloudWatch alarms. And then based upon that, you can trigger your service to scale up and down. You can define the IAM roles. You can define the identity and access management roles. Say, this particular task is going to run in this particular IAM role. So that way, if you have multiple services, you can start defining multiple IAM roles in terms of the capabilities that those services are capable of. It, of course, also everything is trackable using CloudTrail, and it is very well integrated with code build and code pipeline. So think of code pipeline as a container. Code pipeline is where you will have your build system all set up. Think of it as Jenkins actually is on AWS. All right, and then the last orchestration framework that I want to talk about is Mesosphere. So Mesosphere is a company. Well, Mesosphere is not an orchestration framework. Mesosphere is a company behind the container orchestration framework, essentially. And the container orchestration framework itself is DCOS. So, and DCOS is essentially based upon Apache Mesos, which is sort of all the big infrastructure behind it. So what is Apache Mesos? Apache Mesos was started as a research project in 2009 in UC Berkeley, and it was an open source cluster manager. So this is actually predates before the containers were even introduced to the industry. So all it does is it provides resource isolation and sharing across distributed applications. And what does that mean? Okay, well, it says you have a distributed system, which have a bunch of machines, and each machine then has a resource, like a CPU resource, a memory resource, a processing power, and all those things. Independent of where those resources are existing, you want to provide a unified interface to those resources. And then on those resources, you can say, I want to run certain applications. Okay, so let's take a look at it a little bit better. So you can say, now I have a unified set of resources. On that, I may want to run Hadoop or Spark or Jenkins, whatever you want to run. It exposes that interface. It also provides support for cluster monitoring. And behind the scenes, everything is run using Linux containers, so it gives that task isolation. So let's say, how does the Mesos architecture really look like? The concept of Mesos slave is basically those individual nodes where all the work is going to happen. Now, you could have multiple Mesos slave with all different capabilities, and that's where Mesos master provides a unified interface to what resources are available to run a particular application. And on the top, what you have is a different scheduler. So for example, I may have a Hadoop scheduler. The Hadoop scheduler will actually schedule the tasks using Mesos master. Of course, multiple masters can be done, and those masters are configured using a zookeeper quorum. So let's look at a little bit more detail here in terms of how would you really set up the cluster. So first of all, you set up a zookeeper quorum because that's where all your masters are going to be registered. You set up your first master, and then you can set up your standby masters as well. So at a given point of time, there is a single master. Then you can have your slaves, so multiple slaves. This could be VMs, this could be nodes, this could be wherever. If you're running in AWS, these are AWS EC2 instances. And then on the top, what we have is different frameworks that are supported on top of Apache Mesos. There is Spark, Hadoop. These were supported far before, but Marathon is the framework that we care about because Marathon framework on top of Apache Mesos is what supports your Docker containers essentially. Okay. Now, each of these frameworks have an executor, and those executors are the ones that are running in the underlying slaves essentially. So for example, I could have a Kubernetes executor. Now, it goes beyond me. Why would I run DCOS and have a Kubernetes executor on it on top of AWS? I would rather just run Kubernetes raw on AWS. That's sort of my preferred approach. But let's say if you are bought into the design of Mesos, where you want that cloud agnosticism, and you want to be able to run your nodes across multiple clouds, then you can look at that approach where, okay, give me those resources that are available to me, consolidate them, and then I can run multiple frameworks. Or if you're thinking that, hey, I want to be able to run my Hadoop and my Spark and my Kafka and my Docker containers all together as part of a single framework, then you can look at Mesos as one of the things over there as well. So in terms of frameworks, frameworks are targeted at a use case and very domain specific. And that's the ability which really allowed Mesos to evolve and say, okay, we're going to provide a Marathon framework which can now run Docker containers. So essentially the way it works, as I said, a master node offers resources to each framework. The framework accepts that, okay, there's a concept of an offer and accept. So the master makes an offer that I have such and such CPU and such memory available. And then the frameworks would say, oh, I will accept that offer, and here is a task that you run using that offer. Now the framework itself has scheduler and executor. Based upon what all offers have been made, it will actually send an executor using the scheduler. The scheduler basically registers with the master for the offer that, okay, this is where I'm going to execute a task, and executor basically launches a task on the slave nodes. So that's sort of your Mesos terminology to understand this better. And it also passes a description of the task to run. So let's try to understand it slightly better. Now I have my 4 slaves down at the bottom. I have my master. In the master, there is an allocation module. And then on the top, I got my different frameworks. So in this case, I'm just showing a Marathon framework and a Kubernetes framework. and each of them have a job that needs to be executed. Let's say they both have 2 jobs. And they also have a scheduler as well. Okay. So let's say the 2 slaves make a offer to the master that, okay, I got 4 GPU, 4 GB, and 4 CPU. And similarly, the slave 2 says, I have 4 GB and 4 CPU. So to the master, that's a consolidated set of resources that are available. The master, the allocation module within the master will make a request to the framework that, okay, hey, I got these 2 offers. And now notice it's not making the full offer as is. It's not just a pass-through. Master may decide to offer it only whatever is available or whatever it wants to offer. It could do the time sharing between different frameworks. So for example, in this case, it's just passing 2 GB and 4 GB from 2 different offers, essentially. Now, based upon what did the scheduler from that particular framework accepts, it registers with the master. And then the tasks are actually placed onto the slave nodes by itself. And then whatever is remaining, the allocation module can actually offer to the next available framework. Okay? So how do you, and that's far too complex to understand and to run it by yourself. But how do you do this on AWS? Well, essentially, DCOS, again, has built the CloudFormation templates. They're very easy to get started. One of the disadvantages of DCOS that I don't particularly like is there is no local development environment. They claim there is a Vagrant box, but there is none, essentially. Think about running Vagrant on your local Mac, and then running your Mesos, then running master, then running your slave nodes, then running your framework. And in that framework is where you are somewhere running your Wildfly container. There's too much stuff happening on my laptop. It will come to a crawl. Now, you will not be able to see the performance that you really care about. So there is really very little on the local development side in DCOS, particularly, that's available. So pretty much every time I've ended up developing with DCOS, I've always gone to the cloud. And the CloudFormation templates are super easy. It is highly customizable. And I think that's a good side and the bad side as well, because there are too many configuration points and too many choices as a customer or as a developer that I may have to make. I'm happy if you give me less choices and make a little bit opinionated to me. So let's take a look at DCOS here. So what I'm going to do is I'm going to go to DCOS. This is basically, I go to dcos.io. This is their main website. I can go to install here. They claim install locally, but essentially it points you to this Vagrant box. I would not recommend going that route at all. That's at least my personal experience. If you have a big honking machine with 64 gigabyte memory, stuff like that, sure, go crazy with DCOS, install locally. But here I can say install in the cloud. I have 2 options here. So let's look at the AWS options here. And here it shows me all my CloudFormation templates. So I can run with a single master or 3 masters. I can choose a region. So here I'm going with, say, Northern California. Well, I'm in Poland, so maybe I should have chosen a Frankfurt or some other region here. But essentially, it's very much a similar process here. So I can say, OK, create my stack here, and I'm going to call it as DCOS. I'm going to choose a key name here. In DCOS, there is a concept of a public slave or a private slave. Private slave is where nothing is ever exposed to the public. And in a public slave is where typically you could run your Nginx server. Now these guys the containers running on these slaves can talk to each other, but the idea is that the public slave is the one only that's going to be exposed to the public. So I can define, let's say 1 public slave and let's say 3 slave instances, private in that case. I can click on next, and here we are. So somewhere it should be asking me the size for my instances. It didn't. Okay. Well, all I do is I click create here, and that's going to create it. So now, well, this is my region here. So this template is actually working on. But if we go back here, so here is my, well, let's look at the Docker part first, okay? So now I'm in this is US West 2. You can see Oregon region shown over here. So this is the Docker stack here essentially. So in the outputs, it shows me sort of what my default DNS target is. The region has 3 availability zones. So it talks about how you can have a highly available cluster running over there. It gives you the addresses of the managers. And if I look for more details here, I can actually go to EC2. I got a bunch of instances running over here. But now if I sort them here, it shows me that, okay, I got a Docker manager, 3 Docker managers, and 4 Docker workers running for me. So that's pretty cool. Now, similarly, I have same thing running for ECS as well. So it kind of labels them accordingly. And this is a Kubernetes cluster that I started with kops earlier this morning. So that is already running. So that way you can see, you can run those multiple clusters very easily over here. Now, for the DCOS part of it, that stack is still being created. But once it's being created, then you will see something similar for DCOS as well. And for each of them, essentially, whatever your native experience is, you can take the client, you can configure the client to not point to your local environment, but point to your environment in the AWS cloud, and boom, here it goes. So it'll just fire it up for you accordingly. And the last thing that I want to leave you with is where the slides are available. So I'm going to go to my GitHub repo, and I'm going to say docker-java. And if you look at slides here, container orchestration in Amazon, and that's sort of where the slides are available. The source and the PDF are available, so you're definitely welcome to use the slides any way you like. So I think I have just about 3 more minutes, and I'm happy to take questions. And if there are no questions, I'll be out in the hallway, happy to talk to you. Oh, there is one question.
Can you use different Docker images for the ECS? For each node, can each node have different Docker images?
So the question is, can I use different Docker images for ECS? Well, it depends upon, because essentially when you define a task, the Docker image is baked into the task. So what you can do is you can have different tasks, and each can have a different Docker image. That is entirely possible. There's a question up there. Yes, the question is, can ECS scale the machines once the cluster has been originally created? Yes, that capability is there as well, where you can say, add more instances to my cluster.
Which one of these would you use in production? Would you pick Docker or
That's a fantastic question. Which one of these would you use in production? See, I think the way, I played with all 4 of them. So to me, really it depends upon how much time do you have to manage the cluster. So let's go one by one. So Docker is the easiest one for me to get started with, because that's a very seamless native experience. I build my image, I build my container, I do that on my local development desktop. Exact same experience on the cloud. So that is a very seamless migration in that sense from your desktop to your cloud environment. Kubernetes has a bit of a learning curve, wherein you need to understand what is a pod, what is a service, how do I tie these things together, when do I scale it. In both Docker and Kubernetes, you have to manage the cluster by yourself, though. Because yes, you're running on AWS, but those EC2 instances are your problem. You can set up your auto-scaling groups and stuff like that, but if things go down, you are still responsible. DCOS, to me, has a very steep learning curve because of Marathon and containers and all those things. The debugging part of it, what I've heard from customers, is a little bit harder on the DCOS side of it. Although it works very well at a huge scale, for example, if you're running thousands of containers. So that's where it's good at. ECS, independent of whether I work for AWS or not, to me, what matters is the ECS abstractions are not very clean, in my opinion. But once I get those abstractions right, somebody else is managing the cluster for me. That way I can focus on things that I care about. So once I have my images all ready, then I can say, okay, you know what, go ahead and deploy this and scale this and all that stuff. So I think there are multiple ways to skin the cat. So you really have to look at your specific opinion on what matters to you. You know, are you bought into AWS stack? Do you have the IAM roles predefined? Are you familiar with CloudWatch, CloudTrail, and all those tools? If yes, then I think ECS makes us a very logical choice because it kind of fully managed in a very classical Amazon way. But if Docker is what your dream is, that, okay, you know what, I'm going to stick with whatever is offered by Docker, you can certainly look at Docker Enterprise Edition, in which case Docker takes care of, you know, managing your cluster. So there are, and if you're looking at Kubernetes, for example, Kubernetes is offered as a managed service on a different cloud as well. So I think there are options that you can look at it. There is no standard boilerplate answer to this. I think my time is up. So I'll be hanging out in the hallway if you have more questions. And if you like the talk, I would really appreciate a good rating on the app. Thank you.